Hi, welcome to Maths Nipuna, your maths buddy.
Okay, look at question number 9. Mary had a piece of paper. Okay. She folded it exactly in half. Then she folded it exactly in half again. I mean, she folded it two times. First in half and second in half. But they didn't tell what is the position or the direction of the folding. She got the shape as in figure 1. Okay. This is a figure 1. Okay. Which says PQR could have been the shape of a original piece of paper. Okay. So now with CFP, CFQ, CFR, which one could end with this shape at last? This is a triangle. We call it a right angle triangle. Okay. So first we look at the first paper P. This is considered a rectangle. So when she fold it at the first, let's say fold half. Okay. So when she fold up, she will get half of this paper, correct? So she get a square. Okay. Then let's say she fold again, she can fold again. So not necessarily she have to fold in the middle like this. So she can also fold in the diagonal way. Okay, let's say she fold in a diagonal way. So when fold this one to here, she will get this paper, correct? Okay, so it will be it will be something like this. Right? So this and this shape is same. That means P is a possible answer. Okay, next going to Q. Look at the Q. Q, let's say at the first attempt she fold diagonally. Okay. So when she fold diagonally, let's say this one, she fold the other side. So she will get something like this. Okay. Right. She fold diagonally, she'll get something like this from here to here. And then let's say this shape she fold against in from here top to here. Okay, let's say she fold from here to here. So when she fold from here to here, she will get this one 90 degrees. This one 90 degrees and this one. Okay, so she'll get exactly something like this. No. So she fold it. This is, yeah, I had to flip it. Okay, she'll get something like this. Right, so this shape, this shape. Okay. Okay, so this and this is same. So that means Q also is a possible answer. She can flip like this. She get a 90 degree here. 90. This is called right angle triangle. This is 90 degrees. Okay. So the third one R. R, let's say the first attempt she's doing flip like this from here to here. So she'll get this is 90 degrees. So she'll get something. Okay, I have to flip it. Okay, for your so I flip it. So for the first attempt, she got this is 90 degrees is here. So you get something like this. Okay, something like this where this is the constant 90 degree. And therefore, okay, make it big. Okay, let's say you already make like this roughly. Okay. Now she want to flip again. Let's say now she's flip horizontally like this. Okay, when she flip this one is 90 degree, and then you'll get something like this. Okay, something like this, which is also same as the final output. That means both all the three P, Q, and R is possible initial shape to form this final shape. So the question's answer is any of P, Q, and R. Okay, there is a square with line segment drawn inside it. The line segment are drawn either from the vertices or the midpoint of other line segments. Okay, we colored 1/8. Actually, here I show all the colors to make it more interactive, but actually they said they only colored 1/8 of the large square. Okay, so now your job is to find which color is equal to 1/8 of the large square. Okay, so let's say this is our main square. So if you want to make it half of the square, okay, let's say this is my main square. Okay, this one I put aside first. Okay, this is our main square. If I want to make it half, maybe I can cut it to in the middle like this, right? Okay, I have to cut like this. Maybe this become half, this become half, or maybe I can cut horizontally. When I cut here, this become half, this become half. Or one more chance, one more way is I cut it diagonally. This become half, this become half. Okay, but our question is I want to find 1/8 position, 1/8 part of the total area. So let's say first I try to make it half. Okay, let's say I cut it into half like this. Okay, and this is, let's say, half. This is full square, this is half square. Okay, right, this is half square. Okay, I just keep it here. Okay, if I want to make from this half, I want to make it another half, it will be like this, correct? That means half of the half is 1/4. Okay, I give different color. Okay, let's say this is. Or maybe I can cut into this way diagonally. Yeah. So if I want, okay, now I don't want to see this one. I don't want to see this one. I already see here. So now this one I want to make 1/8. As I told you just now, you can cut it half like this, horizontally. Okay, this becomes 1/8. Or maybe I cut it into vertically like this. Okay. Okay, I cut like this. Okay, this is 1/8. Or another method is I cut diagonally like this. Okay, I can cut like this. If I cut like this, what will happen? It will become, okay, I draw a new one. Okay, it becomes something like this, right? Up. I cut up. Okay, it can be like this or it can be like this. Okay, so this is 1/8. So these are the possible shapes we can get at the end. Like this. This one cannot, right? This one 1/4. So where can you see this? Any of these shapes? So it is here, the green color, right? So the answer should be D. That is only the possible answer for us. Okay. So the answer will be, this is already 1/4. Okay, this is also 1/4. This is smallest. This is a bit difficult to find out. So the correct answer is D. Okay, now look at question number 11. The number 050219729070 is written on the sheet of paper. Julian cuts the sheet twice. Okay, that means she cut it twice. We don't know where she cuts. Okay, like this. Maybe she cut like this. Okay, there's a lot of possibilities. What is the smallest sum he can get by adding these three numbers? So that is, so when he cut it small, she get a 3 number. So they want to give you again, they tell you get the three numbers. Okay, they want a smallest number. So here first you count how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 10 numbers means each answer is a 4-digit number. So we can have a 4-digit like this. 4-digit, 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 2-digit. Or to make it more easy, more smaller, we can make it 3, 3, 4-digit. 3-digit, 3-digit, 4-digit. Then also we can get a smaller number. Okay. So normally we want to get a smaller number. What we can do, we can take the because we have 2 3-digit, 1 4-digit. We try to make the 4-digit number is the smallest. Okay, so 4-digit number, it can be like this. This one cannot. Or let's say this is only put 3. It can be like this 4-digit 1972 970 or 2907. So we have two possibilities to create a 4-digit number. So it can be, as I told you, if I cut it here and here, the 4-digit number is 2970. If I cut it here and here, my 4-digit number is 1972. So among these two numbers, okay, there's only that two possibilities where I can make a 4-digit. If I make this one also, I can make 4-digit. Okay, we consider another 4-digit number, which is 5021. Okay, the other two number we consider is a 3-digit number. So it's, yeah. So among these 3 4-digit number, which one is smallest? So 2000, 1000, 5000. So the smallest should be 1972. So you take this as the 4-digit number. Okay, the smallest 4-digit number you can create from here. So when you take this as the 4-digit number, the balance two number you have is 502 and 970. Okay, plus both three. Now you plus all these three, you get your smallest number. This is the method of you finding your smaller number. This is 4. Okay, this is also 4. So this is 4, 5, 6, and this is 1. So sorry, this is 2 and okay, write down here. 2 plus 2 is 4. 7 plus 7 is 4. Balance 1. We have 9 plus 9 is 18. 18 plus 23. 23 plus 1, 24, 4. And then this one is 3. 2 plus 1 is 3. So the smallest possible number you can create from here is 3444. Okay, the map shows 3 stations at point A, B, and C. A, B, and C. Tour from station A to zoo to port and back to zoo is 10 kilometers. This one. And a tour from B to the park. Okay, where's the B to the park to the port. B to the park and zoo. Sorry, this is 12 kilometers. A tour from C to port back to the park is 13 kilometers. And finally, a tour from zoo to park to port is 15 kilometers long. So how long is the shortest tour from A to B to C and back to A? They start from here, go to B, from B, go to C, from C, go to port, and come back to A. Okay. This question, what do you do? You just say, okay, if let's say I take 10, 10 actually equal to, so I put what I can say, I say 10 is equal to this one. Okay, this one plus this one plus this one is 10. And then now I look at here, it's 12. I plus with 12. Okay, what is 12? 12 is this one, and this 3. right? This is 12. And then I plus again 13. I see overall is how much, total, 13. And 13, I have to plus this one, to plus this one, I have to plus this one. Okay. So now when I want to go here, without moving here, so this is actually, okay, and you see, this is actually not, we don't need to count for our path from here to here to here to here to here, we don't need to count these three. So these three, that means now you already count this one, 10 plus 12 plus 13. And then you have to minus with this internal area, internal length. So you just minus with 15. So 10 plus 12 plus 13 minus 15 will be the answer. So I plus all this one, this, then I minus this. Okay, I don't need this one. So this 3 is actually equal to 15. So 10 plus 12 is 22. 22 plus 13 is 35. 35 minus 15 is 20. So the answer for this question is 20. Okay, look at question number 13. So question number 13, Rosa wants to start at the arrow. Start here. Okay, this is the arrow, starting arrow. Follow the line and get out at the other arrow. So she have to follow this line and finally she have to go out in this arrow. Which piece is not possible to put in the middle to obtain that? Okay, when she goes here, okay, she comes here, and then there is no box. Box is missing here. So from here, what we do, we try to estimate. Okay, we try to do some conclusion where she can go. So when I see this one, okay, from here, maybe she can go here and she come here. That is, maybe there is one route. Okay, so or maybe she also go from here, she can go here. She goes here, she have to turn and then she can come here. Okay, or in other way, we want to think about other way. Maybe she from here, she can go here, and then when she goes here, and then she will be moving this way. Then she comes here because this is the outer way. This is the way to go out. Okay, you want to go out, you must come in this way. Anything else? Or maybe she can from here, this two cannot, this two is already ending here. She also can go up. This is also ending. Okay, so now what you do, you try to see which are the routes she can follow. Maybe she can go here, it can be like this, or it can be like this, or it can be like this. Okay, can be like this. So look at this picture. Which picture got this kind of shapes? So picture one got like this. A is already got this one. So it's clearly say when A you put here, she will go and then she'll follow these roads and come out. That means A is correct. A is possible. I mean, correct way. So cannot be answered. The answer they ask us is which road is not possible. That means A cannot be answered because A is correct. Okay, the next look at B. B going straight. Okay, so go straight. Maybe she can go straight. Right, the B is actually. I will put that it can go straight. Go straight, come back, then turn back, and she can come back. Okay, that means the straight line, like look like a green one. That means B also possible of the answer. Look at C. See, we have like this, we have like this, we have like this, we have like this. Okay. C also, when you turn it round, okay, as I take this C, if I turn it around this way, there's a pathway like this, okay. So that means C also cannot be the answer. Okay, now look at D. D, we have a bit different shapes. So if she follow here, she'll go up here. If she follows this one, she'll go down here, down here. So there's a possibility D is not, D is cannot reach the outing arrow. Huh? Anyway, we check E first. Okay, E is a straight line. That means something like green color. It can be like this, a straight line. So that means E also cannot be answer. E is clearly a correct part. So the wrong one is, the not possible is, the only answer is D. Question 14. The diagram shows 3 hexagons with numbers at the vertices. Okay, these are the numbers. Okay. Okay. But some numbers are invisible. That means these numbers we cannot see. The sum of the 6 numbers on each hexagon is 30. That means when you plus these 2, 3, 4, 5, 6 numbers, you get 30. And also here and also here. Huh? What is the number on the vertex marked with question mark? Yeah. Okay, that's the question. You make it bigger. So now, what you do, you try to add all this number. Okay. We have 6 here. Okay, 6 plus 3 plus 1 plus 2. So when I add all this number, okay, 6 plus 3, 9, 9, 1 is 10, 10 plus 2, I get 12. Okay, this one is 12. Okay. When this one is 12, what is the balance should be? Okay, that means what I can do a conclusion that sum of these two numbers, okay, this number and this number, okay, so this is 12, okay, should be the balance, correct? Okay, means 30 minus 12. Okay, so what is 30 minus 12? Okay, 30 minus 12 equal to 18. That means this plus this is 18. Okay, do the same thing on the other side. Okay, I red color. So you plus all these 4 numbers first. Okay, 4 plus 4 is 8. 8 plus 6 is 14. 14 plus 9 is 23. Okay, when you plus all this number, you got 23. When this is 23, okay, what is the balance? That means sum of these two numbers. Okay, this number and this number. Okay, so that means this number plus this number should be 30 minus 23, correct? So which is 7. So now when you see for this box, the third box, here I got 18. Here I got 7. So here I got 1. So what is the balance? So the balance is, so you just start from 30, okay, minus this two number is 18. Okay, this two number is 18. This two number is 7 minus and then minus 1. Okay, you'll get your answer. Okay, 13 minus 18 is 12. 12 minus 7 is 5. 5 minus 1 is 4. Okay, so the answer is 4. Oh, sorry, 4. The answer is 4. Okay, question 15. 3 rectangles of the same height are same, are positioned as shown in figure 1. This is figure 1. The number within the rectangle indicated the areas. Okay, the area of this rectangle is 12, this is 18, and this is 22. If AB equal to 6, how long is CD? They ask you to find this CD. Okay, this question, what I do, I make it bigger. Okay, maybe I make it bigger, little bigger. Okay, okay. So what's the formula for area? I think you all already learned in your schools. Normally, area of the rectangle equal to the length times the width. Okay, so length times width, the area. So you have to know this formula first. Okay. Now let's say this is the length, this is the width. Now we have three rectangles. Okay, all combined together. But first they give you this length, okay, AB. Okay, so when give you this length, from this length, what I can see from this length, 6. Okay, so this area, just look at the red color. Okay, okay, this area is 18 plus 12, right? So the area equal to 12 plus 18 is equal to 30. Okay, make it little bigger. Okay, the total area of this area is 30. These two triangles combined together. Okay, if this area is 30, so our formula is area equal to length. Let's say this we consider the length. Okay, length is 6 times the width. Okay, so from here you can see what is your width. If 30 equal to 6 times what, you get 30. So you can estimate the width must be 5 because 6 times 5 equals to 30. Okay, that means what we can do conclusion here, the height of the triangle, okay, or height, or we can say the width of the triangle is 5 now. Okay, they use the height here, so I also use height here, no need with length times height, same only, no problem. So the height is 5. Okay, so the height is 5. So when this height is 5, this height also must be same because they say the triangles are having the same height. Okay, now look at the second part of this triangle. Okay, maybe now you look at the right hand side. Okay, okay, use another color. So you look at these two triangle now. Okay, this triangle, this triangle, this triangle. Okay, these two triangle now. Okay, so I think I use another color. I cannot see. With this triangle, I just shade it. These two triangle now. I want to check with these two triangle. Okay, now what is the total area of these two triangle? 18 plus 22, which is equal to, it means up to here, CD times 5. 18 plus 22 is 4. Okay, so now use the same formula again. Area is length times height. Okay, so now our length is 40. Okay, our height we know already 5. Okay, height is 5, we already found. Times CD, the length. Okay, so 40 times 5 times CD. So what is value of CD? CD should be 1 times 5, you get 40. Normally, if you're higher level, you can just divide 40 by 20. Or if you're level, maybe you can just think how to solve this one, because 5 times what number, you can get 40. Okay, so the CD is 8. So 5 times is 40. So the length of the CD is 8. So the answer is C. Ronja had 4 white tokens and Ronja had 4 white tokens. Okay, Ronja has white token. And then Wanja has 4 gray tokens. Okay, this is the keywords. They played a game in which they took turn to place one of their token to create 2 piles. This is called piles. This is 1 pile, 2 piles. Ronja plays a first token. That means if we start with Ronja, we start with Ronja. Okay. Which pair of piles could they not create? Okay, that means when Ronja put we start with Ronja, and then Ronja and Wanja. Okay, they put one after on. So let's say we see here. So let's say we start with okay, Ronja, put R. Okay, I put Ronja red color, and I have Wanja. Okay, Wanja and Ronja. Okay, Wanja. Let's say I say it is okay. What color? Okay, same only pink and red. Okay, blue color. Okay. So first we start with Ronja. So look at A. Let's say assume this is Ronja because Ronja has 4 white tokens. It must be here or can be either way. Ronja put here. The next one can be this one or this one, either two. So this one cannot be because Ronja has the gray color. So Ronja must put this one. Okay, now Ronja got white color. So Ronja must put this one here. Ronja can put here because this is gray. Okay. Now it's turns Wanja's turns. Okay. Wanja only can this can be Wanja's one because this is gray. This is white cannot. Okay. And then next Ronja, she can put at top here, white color. And then Wanja can put either here, either two, one of this one. So let's say Wanja put here. And then if Wanja puts here, Ronja cannot put here because next must be a white color. So maybe in that case, maybe Wanja put her coin here. And then finally, and then Ranja, white color comes here. It's the possible, that's a possible. Okay, possible. And then finally, Wanja may be put at this one. So this is how we can solve the first one. That means that's first one can be the answer. It's a correct. Okay, that means it cannot be answered. Okay, as a correct because they ask us which one they cannot create. Okay, now the same thing. We start with Ronja 4, Wanja 4. Let's say Ronja starts, let's say Ronja puts here. The next one can be this or this. So sure this one cannot be Wanja. Wanja must be gray. Okay, and then Ronja, maybe she keeps here. Okay. And then Wanja can be this one or this one. So Wanja can be here, only can be here. And then Ronja white only can be here. The next one must be gray, Wanja, okay, can here or here. Doesn't matter, we put here. And then Ronja maybe put here. And finally, Wanja keeps here. I mean, this is also possible. This is also correct arrangement. So this also cannot be answered. Look at third one. Okay, we have Wanja. We have Ronja. We start with Ronja, white color. And then Wanja either can put here or can put here. So we put here because we want to next be a white. So when Wanja goes here, Ronja will go here. And then Wanja, okay, I think after this you can understand Wanja goes here. Next is Ronja. So Ronja, there's a place to put white here. And then Wanja, maybe Wanja put here, correct. And then Ronja can keep here and Wanja can keep coins at the top of the second pile. So this is also possible. So it cannot be answered. Look at the next one. Let's say Ronja must start here. Okay. Ronja only can put here or can put here. So we say let's see puts here. Okay. And then Ronja can put here and Ronja must be here or here. Okay. So we don't put here. We don't put here. Okay. If we put here, Ronja can put the next white. So let's say we assume Ronja puts here. And then Ronja puts a white color. And Wanja put a gray color. Ronja put a white color. Wanja put a gray color. So this is also not a possible answer. It can be happen. Now look at the last one. Maybe this is the answer. Ronja, let's say, puts here. And then Wanja, she can put here because the gray. Next one can be here or either here. So sure, Ronja puts here and Wanja puts here. Next, Ronja must put a white color. So this is also gray. This is also gray. So there is no possible Ronja put anywhere. Okay, that means this pile cannot be created using these rules. Okay. So the answer is E.